Okay, in this station we have a small boat that traveled 29.5 miles upstream in 2 hours. Then the same boat took 3 hours to travel 59.25 miles downstream. If the speed and the direction of the water was the same in both directions, find the speed of the boat in the still water and the speed of the current. Okay, so an important equation that we're going to need to solve this is the distance formula. The distance formula is the distance equals rate times time. Okay, and that comes up a lot in physics and in some math problems that we do. Okay, so we're going to use this, the distance equals rate times time, to make our two equations that we can solve here. First, I'm just going to make a little chart because our boat's going upstream and it's going downstream. And I'm just going to write down some numbers that I know. Okay, well, going upstream, I know that I'm traveling a distance of 29.5 miles. Okay, so my distance is 29.5. Then when I go downstream, I'm traveling 59.25 miles. So I can say my distance equals 59.25. Then it also tells me my time. When I'm going upstream, it takes 2 hours. So my time equals 2 hours. And when I go downstream, my time is 3 hours. So time equals 3 hours. Okay, now I need to figure out what my rate is. My rate is going to come from what I'm looking at. My rate is the speed. And it also tells me to find the speed of the boat in the still water and the speed of the current. Okay? Well, I can call my speed S, and I can call the speed of the current C. Now, my rate would be the speed of my boat, and then it's going to change depending on what we're going to talk about. Because if we're going upstream, we're talking about the speed of the boat, but we've got to subtract the rate of the current because we're fighting against the current. But if we're traveling downstream, then we're still going the speed of our boat, but we're no longer fighting the current, so we're going to add the speed of the current because the current's actually going to help us rather than slow us down when we're going downstream. Okay? So now that I have all these written down, I can write my two equations. My first equation for going upstream is going to be my distance, 29.5, is equal to my rate times time. So 2 times S minus C. Then my second equation is going to be 59.25 is equal to 3 times S plus C. Okay. Now that I have my two equations, I need to solve this some way. I'm going to do this by elimination. How I'm going to do that is I'm going to times all of this by 3. And I'm going to times all of this by 2. Okay. So that's going to turn into 29.5 times 3 is going to be 88.5. And then that's going to give me 6S minus 6C. And then for the second equation, 59.25 times 2 is going to be 118.5. And then I'm going to end up with 6S again and plus 6C. Okay. Now I notice that this top one, this top negative 6C and this bottom positive 6C are going to cancel each other out when I add these together. So I'm going to add these together, and I'm going to end up with 88.5 plus 118.5, which is 207. And that's going to equal 12S. And then these two numbers are going to cancel each other out. And then to get S all by itself, I'll divide both sides by 12. 207 divided by 12 gives me S to be 17.25 is S. And now that I know what S is, I can use this to find my other variable. So I can plug S into any one of these equations here. So I will plug that into this top equation right here. So let's see, we've got 29.5 is equal to 2 times 17.25 minus 2c, because I've still got that c there. Okay, so that's going to give me 29.5 is equal to 34.5 minus 2c. So then I've got to subtract 34.5 from both sides. If I subtract 34.5, it's going to end up negative 5 equals negative 2c. And then negative 5 divided by negative 2 on both sides gives me 2.5 is equal to my c. So the current speed is 2.5 miles per hour, and the speed of the boat is 17.25 miles per hour.